Hello, everybody. I'm Robert Barton. I'm here at North Carolina State University and would like to introduce you to our webinar today. Our host is Sean Tanger with the University of Arkansas at Monticello, and they will be covering the topic of future directions for hurricane-disturbed forest. And with that, Sean, I'm going to turn it over to you.
Thank you, Dr. Barden. Welcome, everybody. Really glad you could join us today for this lunchtime webinar. As you saw already from registering, today we're going to talk about future directions for hurricane disturbed forests and research and perhaps some outreach efforts in that area. Before we begin, I just wanted to say you'll notice that the host is Arkansas Center for Forest Business. You're like, why would Arkansas care about hurricanes? This is actually work that an event that stemmed from collaborative with Dr. Bruno da Silva, Dr. Mohammed Maroufaz, and many others that you'll see speaking today. We started a small hurricane and high winds research group called THOR. Let's try to be clever there with the acronym. So Tree and High Wind Research. The project was funded, at least in its infancy, by the Forest Service, particularly Dr. Jesse Henderson, who's joining us today. And so from 2 or 3 people, we've built up to a group of about 10 or 12 now. And so it's been really fun to work with everybody and get that going. I'd like to thank forestrywebinars.net and Dr. Bob Barden for hosting us. We didn't budget in the grant originally for this, so I had to come out of pocket for it, but it's money well spent, and I hope you get to enjoy the meeting today. Before we get into the nuts and bolts of things, though, I want to give our condolences to those affected by the storms, both Hurricane Milton and Helene. I was looking the other day at the highly reputable source, Wikipedia, and the initial estimates are around 75 billion in total cost just generated from the 2 storms. Obviously, small percentage of that is timber resources, but nevertheless, pretty devastating effects, as many of you have already seen through other media and news outlets. So we want to make sure that we keep them in the backs of our minds as we try to come up with new directions and solutions for those people. Right, the flora and the fauna and the humans that are affected by these events are why we do this. That's what really matters. So. As Dr. Palenko said in the previous webinar, current research that was done on October 7th, we did several talks that I'd like you to go back and look at some point. As he mentioned, we're scientists, and so these are cool problems to us, but cool in the scientific sense only, certainly not cool in the sense of, the things that they cause. And so we definitely want to caution all of our work with that in mind. Let's do a quick introduction with our panelist. Just if you would chime in, give your name, occupation, and employer. And if you have a quick plug, feel free to add that in as well. Could we start with Dr. Jeffrey Cannon?
Hey everyone, thanks for joining. I'm Jeffrey Cannon. I'm a landscape ecologist and I work at a nonprofit research center in Southwest Georgia called the Jones Center at Itchaway. And so I've been doing work on different kind of forest disturbances from hurricanes, tornadoes, prescribed fire, wildfire for about 10 or 15 years now.
Thank you. Dr. Chastain?
Morning, I'm Robert Chastain. I'm analyst at Redcastle Resources on site with the Geospatial Technology and Application Center, Forest Service Technology Center in Salt Lake City. And a couple of weeks ago, I gave a talk on some analysis that we do immediately after hurricanes to try to predict patterns of forest damage before we even have a chance to get remote sensing data, of any sort. So we can give people an estimate of patterns of damage and maybe extent of damage after large hurricanes within 24 to 48 hours. And I'm happy to serve on this panel today. Thank you.
Christine, Dr. Fortune?
Hi, I'm Christine Fortune. I'm an assistant professor at Mississippi State University in the Department of Forestry. I am a disturbance ecologist and forest entomologist. I'm interested in various types of forest disturbances, including both tornadoes and hurricanes.
Dr. Palenko.
Hello, I'm just down the hall from Dr. Fortune at Mississippi State University. I'm an assistant professor of silviculture here in Starkville, Mississippi. And I study silviculture and forest stand dynamics. Forest stand dynamics being stand response to disturbances. And that in my world is all the way from thinning response to uh, disturbance after extreme events. So happy to be here.
Thank you. Dr. Henderson.
Hi, I'm Jesse Henderson, research economist with the U.S. Forest Service Southern Research Station. I'm located in North Carolina, RTP, and my work on hurricanes has been largely around developing economic models, looking at long-term and short-term impacts. Thanks.
Dr. Da Silva.
Hi, my name is Bruno da Silva. I am an assistant professor at University of Georgia in forest finance. I've been working with hurricane the last few years, similarly to Dr. Henderson. I'm interested to see the short-term and long-term impacts of hurricanes and how it would affect the financial returns of timberland investments.
Thank you. And Dr. Crosby.
Hey, Michael Crosby, associate professor at Louisiana Tech. Handle a lot of the spatial classes in the forestry program. My research is generally in disturbance detection and biomass modeling.
Thank you. Thank you. All right. So for today, just a little bit of a framing issue because we've got 8 or 9 speakers here. Things could get pretty unwieldy if we're not careful. I want to keep our responses, at least in the back of our minds, this framework of findings as relevant to resistance and recovery / resilience for forest systems. And honestly, the stakeholders maybe that hold them. We think of the forestry side, but certainly the human side is relevant there as well. You know, as they're affected by these hurricanes and even other high wind events when those are relevant. I know Dr. Fortune had some tornado results that she went over in the initial seminar a couple of weeks ago. So make sure to check that out. It's pretty interesting findings there. And so kind of a quick definition or example, I think of this, you know, to picture it in your mind's eye. Think of your sigmoidal kind of volume curve on a stand. If you have a stand, if it's very resistant and a hurricane hits, then there's no movement, right? There's no shrinking inward, as it were, of that volume curve. And in fact, if we solve the resistance problem, again, highly stylized and unlikely outcome, then there really is no recovery problem. And so that would be nice. As best we can strengthen that, we would like to. But then on the recovery side or the resilience side, and I got to give credit to Dr. Palenko. This is his framing as through our discussions that I'm using here. So Adam, correct me if I goof it up terribly. But for resilience, think of it as, you know, after we've been knocked off of that typical curve that we would expect, that we would predict, how quickly does our forest, or does the forest at all, get back on that track that it was on prior, and how long does that take, and what are, you know, kind of the consequences therein. And so that's kind of a general frame that we want to use with respect to our responses. And then we've also got people from several different backgrounds here, and I want to group those in ecology and silviculture, and then economics and operations, and then geospatial. Obviously, with that last group, there's a lot of overlap with the first two. And so if you're speaking in context of ecology and silviculture, and one of the findings that you want to talk about is more brought from a geospatial perspective of the paper that you may have written or that you were interested in, that's fine too. And we can double back later and wrap up the any outstanding geospatial questions. For the audience, we'd like you to feel free to drop questions in the Q&A. And as we go through, if the question is relevant you know, to the current discussion we're having. I'll try to push it in there as best I can. If we don't get it right away, you know, don't worry, we're keeping a log of these, so we'll try to get to it at the end. We'll try to keep 15 minutes or so at the end for questions. And then if we still don't get it, then you can email me at tanger@uamont.edu, and I'll get that question directed to somebody who can answer it for you. So just make sure to put those in the Q&A. Don't put them in the chat, because it's just, there's too much traffic and it's hard for me to keep up with what's been answered and what hasn't been. All right. With that, I mean, the real premise is to discuss kind of future directions and needs in order to achieve the research that we're going to recommend as future areas. But in order to do that, we kind of need to know where we are, where we've been. And so I kind of want to spend 15 minutes or so talking about some of last week's findings and in those buckets that I mentioned, and maybe some other findings that weren't talked about in the previous webinar, but that are relevant to the overall direction that we're trying to take here. And so just trying to get some value in summarizing those major findings, how they can inform the future work that we'll then talk about here shortly. Okay. And I know some of that was done already in the first webinar. If you go back and watch that, I think both Adam and Christine and even, well, all four actually mentioned, hey, here are some good next steps for the, pivoting off the research that we've done. And so it's fine to bring those back into the discussion today as well. Oh, one last thing. I was listening to the other week. There was a small complaint, slight issue about acronyms. Keep in mind the audience may not be familiar with those. So if it's something like basal area, or okay, we don't want to define everything, but things that are like vegetation metrics, or indexes, kind of give a little bit of detail about what those metrics are, why they're, what they're used for, and things like that. Just to give the audience a little bit of bearing on that in case they're not familiar with it. All right, enough preamble. Let's get into things. So we'll start with the ecology and silviculture grouping. Again, it's not limited just to them. If you have a point and you're in one of the other groups, please feel free to jump in there. Let's start with Dr. Cannon. He's been generous to donate his time to us today, and he wasn't front and center at the last webinar, so we'll pick on him first. One paper, Dr. Cannon, that you shared with our group indicated an interesting finding with respect to planting density in the longleaf pine systems. Can you talk about that a little bit for the audience, kind of why it's relevant, what the finding was, and then we'll go back and forth with you and Dr. Palenko and kind of flesh out from there.
Yeah, sure. And I might, so thanks for having me. And I'll start too. Before that paper, one of the things that got us interested in studying hurricanes in general was Hurricane Michael. And one of the things that we started looking at was just to ask how common are hurricanes in the coastal plain. So we did a study, and maybe I could talk about this more in the geospatial section, but we looked at some modeling of past hurricanes and just asked the question, how common are they? What was really interesting is I study longleaf pine forest, which historically covered a lot of the southeastern Gulf coastal plain. And this is an organism that's about 300, that can live to be about 300 years old, even more, but 300 is, it would be a mature, a ripe old age, although they can go well beyond that. But, in the lifespan, the 300-year lifespan, we might expect a tree of that age to experience about 50 tropical storm winds. So this can be, we think about, and a lot of attention is drawn to really intensive impacts, but we get in this region lower intensity winds all the time. And so that kind of got us interested in looking at the ecology of the system, how hurricanes contribute and might shape ecosystems. But the specific paper that Dr. Tanger was describing was a study where we looked at the impacts of Hurricane Michael. And so our goal was to try to provide landowners with some guidelines of how to build and shape and grow hurricane-resistant forests, ones that could withstand some hurricane winds. And so after Hurricane Michael, which impacted it made landfall in Panama City, Florida, and went northeast through Southwest Georgia, all the way up to Albany, Georgia, where I live. So it made, and even though we were, 100 miles, 150 miles inland, we still got Category 2 impact. So we had this, like Sean said earlier, these are pretty big disasters for a lot of people, but for scientists, they represent pretty good learning opportunities. So we had, from stretching from Florida to Georgia, this gradient of wind impacts. We also had an area that historically includes a lot of quail hunting estates. And so there happened to be a lot of longleaf pine concentrated in that area. So it was a nice opportunity to try to understand how, we might build more wind resistant forests. So we studied, and this was in collaboration, the study was led by Andy Whalen, who's now with the Colorado State Forest Service, and Seth Bigelow, who is with Tall Timbers Research Station in Florida, and several others from University of Alabama. But we investigated all of these planted stands of longleaf pine that varied in their density and size and variability in terms of tree size. They also varied somewhat in their landscape context. So some were next to fields, some were embedded in more continuous forest. And so we looked at some of the different factors that led to wind resistance. And overall, what we found was that trees that are emergent, so sticking out of the canopy, trees that are taller than a lot of their neighbors, can be a lot more vulnerable. We found that trees that are near edges can also be very vulnerable. Wind can move rapidly across open fields. And so, those intersections and edges can be vulnerable. So it's a little counterintuitive. One of the, if we're trying to talk about managing longleaf pine forests, it's a ecosystem that is managed with very open stand structure, and that's necessary to increase light and biodiversity and the use of prescribed fire. So it's a little counterintuitive, because one of the recommendations that you could make from this study, we found that high density stands tended to be less vulnerable, so planting trees closer together. That's a little bit of the antithesis of managing longleaf pine forest. So in the end, the recommendations we made to try to meet these economic reduce your economic risk, but also get the ecological benefits of longleaf pine, was to continue with open pine management, but really focus on increasing taper in trees. So trees that are very wide have a large diameter for a given height. So you can do that with frequent and early thinnings to promote more lateral growth, increase taper, which can drop the center of gravity of an individual tree. So we were trying to balance the ecological objectives of longleaf pine to some of the specifics of reducing wind impacts. So I'm happy to chat about that more, but I've gone on pretty long. I know Adam's got some studies that are complementary too.
Yeah, let's kick it over to Dr. Palenko. Dr. Palenko, you and I've talked about this in the past. A lot of the studies that I found, looking at these different relationships, they were very old studies. They were stands that had been kind of turned loose after the research proper had been done, and people had gone back to them later. The study you presented the other week, though, looked like it had a much more kind of operationally realistic density and basal areas, things like that. Is there anything you want to add on to Dr. Cannon, or at least kind of a jumping off point there?
Yeah. There's a couple things that came out of that study and that tie into Dr. Cannon's research. Certainly in the even age stands that we presented a couple weeks ago, they were closer to your more traditional even aged pine management in general. Still kind of relatively low density. I think we were at about 400 trees per acre or so. So in your traditional pine management, maybe a little lower than normal, but still we found that effect with resilience, with resistance to Hurricane Ivan, that maintaining that density effect just kept those crowns small, and increased resistance in those stands, especially relative to the uneven age stands, which had a much wider distribution of age classes. And so you ended up getting you lost some basal area in those uneven age stands, especially in those larger diameter classes. So I mean, it's quite counterintuitively, the typical longleaf pine management that we're aiming to do, like Dr. Cannon mentioned, your restoration objectives that are often closely tied with fire, because that's a more familiar, frequent disturbance that we tend to implement on the landscape. Those stand structures are inherently, as you progress through time, are less and less resistant to hurricane damage, just because trees they keep getting bigger, right? So that's not necessarily exclusive to uneven age management. That's certainly the case with even age management as well. As you hold that risk for longer and longer, those trees are getting bigger and bigger. And if you subscribe to if you just look at the probability, your risk is changing and increasing as you move forward through time. But interestingly enough, that study was one of the few to look at resilience to hurricane disturbance as well. So how does that stand grow in response to that disturbance? And just like you would expect, having those lower, younger cohorts of smaller diameter trees, although initially you probably most likely have a little bit of a thinning shock, as those crowns are exposed to light and haven't necessarily been growing in highlight environments. Those trees are remaining and ready to reoccupy that growing space, which is certainly a benefit. So on one hand, from the uneven age side of things, or the landscape restoration of longleaf pine, we're simultaneously decreasing resistance but increasing resilience, which is I think is an interesting equation, and I guess that's the same for even age stands as well. If you are a landowner that simply can't just balance your risk profile across stands that are more susceptible and less susceptible, that's the whole reason insurance companies make profit, and at the end of the day, balancing that risk. If you're a small landowner, it may be challenging to plant at higher densities to offset that hurricane risk and decrease the impact from a potential hurricane, especially with changing markets. I know that's a topic for the next session, but that I guess if you can't change your practice to decrease the risk through density management, I guess the other option is try to outrun everything and bump up the intensity to try to shorten the rotation. That's another option as well.
Yeah. I think Dr. Fortune, you mentioned something interrelated here, where it looked like there was a bump around 40 to 60 in the height. Was that attached to stands coming out of thinnings, or was that across different thinning regimes?
Yeah, that was across different thinning regimes. We found that the time since the last thin was the most important factor in terms of the management, right? Because we were able to get data on historic management and when the stands were last thinned, and the ones that were thinned within the last 10 years. It was definitely like a sort of a 10-year cutoff. And so the dominant height was kind of an independent effect that we found of, between 55 and 75 feet. And then it starts to drop off a little bit after that. But I would also echo what folks have been saying about stand density and density management. We found the same thing, that density was the most important factor in predicting the severity of damage of a stand. which can, obviously is also linked to thinning. But we also found that these effects were most pronounced within 50 miles of the coast. So it also depends where you are. And Hurricane Michael was an especially intense storm. So that 50 kilometers from the coast may not apply to every single storm, right? We need to do more replication to really determine that. But there was a significant drop off in severe damage within 50 kilometers from the coast, at least in these loblolly pine plantations. So the density management, I think, is really important within that range in particular.
What else, guys, on the ecology and silvic side? I just one last thing maybe on the density. So we're getting, and I don't want to front run the next section too much, but we're getting, as economists, we get pressure from the landowners. Hey, pulpwood markets, they're gone. What do I need to do? Now there's a big push, has been, to start out with a lower density. I've had people tell me, well, if the trees start out in a lower dense environment, right, they're going to put out better lateral system, things like that. So their individual tree characteristics might be a little more robust, even though they don't have their cohorts around them. Is there much work done in that area, or is that just because markets have been so recent in terms of their downturns, there's not much in the way of what that could mean for management?
Well, Sean, I would also add real quick while we have the ecologists talking. How do these, like, if you optimize a stand for hurricane resilience, how would that impact resilience to pest disease, resilience to fire? There's some trade-offs here, right?
Mm-hmm. Yep, good point.
I'll speak to that a little bit. One of the potential trade-offs, I think one of the trade-offs we've seen, so longleaf pine compared to a lot of other southern pines, we did a study after Hurricane Michael where we compared several different southern pine species, shortleaf, longleaf, loblolly pine, I think were the ones that we had large enough sample size to investigate, and found that over most soils, that longleaf pine tends to be much more wind resistant than some of the other pines. That effect sort of fades away on the really dry soils. I think on the very dry soils, everything gets very big tap roots, maybe grows a little bit shorter, these kinds of things that evens the playing field a bit. So longleaf pine is one that we are kind of thinking about for being more wind resistant, hurricane resistant. It also is one that's managed with fire and has a lot of traits that are compatible with more frequent or more severe fires. It also tends to be a drought resistant plant. It uses less water. And so in a lot of ways, I think some of these are compatible at an individual level. So pine also uses less water. There's even some research around restoration at large scales to decrease evapotranspiration to the point where you can even see an increase in stream flow. So it's being used to address many of these climate adaptation problems. So, at least from my view, a lot of these things, hurricanes, fire, and droughts, I don't know as much about insects, but I would suspect with those other three, it's pretty compatible.
I see a question. I think there's some more, and I'll get to them there, Carl. But one thing, it's in the chat, so I don't want to miss it. From Josh Dasher, any analysis or study yet as to why in South Georgia and possibly other areas that the hardwood bottoms, Branches and Creek, riverbed areas took such a hard hit with so many trees down, broken off, or bent over from Hurricane Helene? Toombs County, Georgia, along the Altamaha River area, sorry, I butchered that name, got hit hard in the hardwood bottoms, not just the pine timber stands. And so, from my limited experience, I know that pine is much more heavily studied just to its commercial appeal, but with so much new markets for bottomland hardwoods, particularly in carbon, do you guys have much in way of adding a wrinkle for hardwoods there in the context of our discussion, or with that question there? So, long story short, why would that storm hit those areas? Maybe not maybe it wasn't harder, but maybe the perception of it hitting them more heavily than pine.
Well, as most foresters know, your sites differ pretty dramatically between bottomland hardwood sites and pine sites, particularly in soils. And I know this is an area that Robert has looked into a little bit with his tree dip model, but specifically, I can't think of a study that has looked at that. But my hypothesis would be, differences in soils. Your precipitation interacting with soil saturation is affecting that pretty dramatically. Robert, do you have anything to add to that?
Yeah, the type of modeling I've been doing is I'm applying the Gales model. Forest Gales is the sort of subset specific model, and that's really the most sensitive, the most emergent variable in there is modulus of rupture, how strong the wood is to breakage. When they do those experiments in the woods where they winch down a tree and see how much force it took to bring it down. So that goes up against the wind model we throw at it. And if the wind model says, yeah, that's a strong enough wind to break that tree bole, it's based on the modulus of rupture. It's like it's trying to predict, is that wood stronger or weaker than others? And obviously oak is much stronger. It's like in the 8,000s typically for your oak species. And we end up seeing a lot of like branch breakage, but not bole breakage, to hurricane winds. And the oaky sort of usually not in the uplands, but kind of in the lower, bottomland hardwoods sections in between. Lolly pine has a much lower modulus of rupture than longleaf pine. So yeah, the prediction of that model would again be that the longleaf pines are going to be more resilient, more resistant to that wind field we're throwing at it. And it's like we're generalizing over landscapes. So you can't look at a tactical scale and say, well, in this particular area, damage was much higher, because we can't really predict very well where those wind eddies and small tornado like eddies, whether they're full-blown observed tornadoes or just eddy-like activity in the bands of the storms, are locally knocking down a lot of trees, but can generally at least get a ballpark, within 24 to 48 hours landscape view of the level and location of heavily damaged areas based on the storm's track. But yeah, thanks for the question, because it does kind of point to like, this is the best we can model on the landscape scale with the Gales model, is how strong are the trees and how strong was the wind there. And another emergent variable we do throw in there to kind of reiterate a point that was already made is those emergent tall trees. We put tree height into our model as well from most recent land fire data we can get to try to predict, taller trees we expect to get knocked down quicker, to help the Gales model predict those patterns of damage on the landscape scale. So thanks for the question on that.
One thing I'll add too, I've seen a study of, I believe it was after Hurricane Katrina, looking at the Mississippi alluvial valley, and they were looking at a pretty large range of soil types and found, I think, what Dr. Polenko mentioned about some of the very wet saturated soils. And then just remember how there's far less development of tap roots, and so uprooting and is much more common in those situations with saturated soils. One thing that's really counterintuitive, though, we did a study recently where we wanted to test the idea that saturated soil can make trees weaker, and we did one of those winching studies that Dr. Chastain just mentioned, where we climbed up trees, pulled them down with a winch, and measured the torque needed, and actually found that adding water to the soil made them stronger. So that sounds in conflict to what I just mentioned about saturated soils being weaker, but the difference seems to be whether it's short-term versus long-term. So in long-term saturated soils like floodplains, there's much less root development or much shallower root development, so you get thinner root plates, and those root plates are essentially a counterweight that counteracts the torque of the tree. So when those are really large and developed and deep, that's a large counterweight. When you have very saturated soils, that doesn't occur as much. What we did was we added soil to kind of replicate short-term a rain event in an otherwise well-drained dry soil. So we added all this water, 4 inches of water. We simulated a rain event, and what we found is it actually increase the weight of the root ball. So when we pulled the trees up, it actually took more force to pull those over. We should have realized it ahead of time, but that difference between the long-term soil moisture that impedes root development versus the short-term addition of precipitation, which can increase root, kind of the root mass and weight. And then I think there might be some exceptions to the vulnerable bottomlands, and that would be species like, from my observations, I don't know that data on this, but bald cypress, and tupelo, which has these really wide buttressed bottoms with a very, very low center of gravity, tend to do very well, even in saturated soils and even in river bottoms. And then one other thing to mention is that remember that intense winds are also a fluid, and they move through the landscape as a fluid. So, channeling down riverways where there's less resistance can happen. I've seen this in pecan orchards where, depending on the orientation of the rows, wind may penetrate or not based on whether the rows are oriented in the same way as the wind. So other those kind of topographic effects can come into play with making bottomlands more vulnerable.
Thank you. Yeah, great points. One question from Carl DePold. Any thoughts about climate smart forestry practices as they pertain to the discussion we're having now? Is there positive feedback loops for hurricane resistance and recovery, or maybe is there conflict there? I mean, climate smart forestry practices entails a lot of things. So, just as best you guys want to tiptoe into that.
Yeah, that's certainly an interesting issue. I guess in like from what we know about, or what we think we know about the predictions for climate change in terms of hurricanes, the potential for maybe stronger storms, frequency maybe still out there. In terms of predictions, we don't quite have a good grasp on that, but the idea is that we're going to be dealing with these for quite a while, and so being okay with losing a portion of your stand to a hurricane with while being able to recover from that disturbance relatively quickly with trees still on the ground, that's definitely a good strategy, I guess, that would be more on the uneven age management side. But I mean, the reality is that most landowners don't have existing uneven age stands, and making that transition from even age to uneven age, even though that might be the most resistant and resilient, is usually financially prohibitive, because it comes at a significant opportunity cost to move that mature stand to an uneven age stand. And so in that case, even age management, you're shortening the rotation, just reducing the risk by matter of time investment, is probably your best strategy, because at the end of the day, most landowners are maintaining forests for some source of income, and we can talk about resistance and resilience, optimal strategies for optimizing those aspects of stands moving through time, but a lot of those actions are financially prohibitive. So I'll set it up for the economics folks.
Yeah, you felt the disturbance in the force. I was just getting ready to switch over. So thank you, Adam. That's good webinaring right there. Dr. Henderson and Dr. Da Silva, can you talk a little bit about prior research that you have done, as well as others, kind of broadly speaking? Talk about pre and post storm timber markets, what the landowner's facing, how long they're facing it, kind of what the levers are that are causing that supply, demand, et cetera. And then expound on that in any direction you'd like to go from there.
Who first? I can go first, maybe.
Walk the plank.
So I guess for one, talking about the economics research on hurricanes, I would say, economists, we care about prices, we care about forest product markets. So that's kind of like, the beginning of the discussion in terms of the history of papers. And I guess the big picture there is, there's a short-term decrease in price because you're averaging in all this salvage wood, which fetches a lower price, right? And then a long-term increase in price compared to if the hurricane didn't happen. So Jeff Prestiman wrote some papers along those lines that are pretty well cited. And what I've done, some of my work recently, I modeled, pine markets and hardwood markets in response to Hurricane Michael. And quickly, when I'm putting this model together, I'm discovering what we don't know. A lot of the things we have to assume in this kind of modeling exercise. So the salvage rates are kind of all over the place. But if you pick a number, pine salvage rate is about 25%, and then hardwood salvage rate is in the low single digits. So that's another reason, pertaining to the question about hardwoods, forest economists, well, most of the salvage isn't there, so there's not really that kind of disturbance in the markets if they're not salvaging at high rates, and maybe it's gets kind of washed out. But that's definitely an area where there's a lot of research potential in looking at impacts on hardwood markets. What would be the impact of increasing that salvage rate? And then related to climate smart forestry, this salvage question, how much can we salvage? It has a lot to do with how much carbon is released from the disturbance. So if we can get the wood off the landscape where it's going to rot and into a forest product or a house or something like that, then we could potentially store some of that carbon. So I will hand it off to Bruno, and then we'll continue.
Yeah, Bruno, maybe talk a little bit about, some of the operations work. So Jesse's talking about prices and these responses from landowners, but maybe get across to the audience the transportation cost and the timber movement aspect of after these storms.
Yeah. So as Dr. Henderson mentioned, there is expected that we have a decrease in prices. The ratio of this decrease, that is a big question. So and for different products, I would say that pulpwood would decrease a little bit faster because a lot of saw timber on the ground are downgraded to pulpwood, which will feed these pulpwood mills or pellet mills. And then saw timber, it might have a decrease in prices, but my hypothesis would be, well, the price will increase a little bit faster later on. Given that we have a very big impact, right? But also we have to think about what's going on in the US South in terms of inventory. We have a lot of timber over there, so it's not like the mills will lack timber in the future. There will be timber resources spread all over around them. So initially, what is possible to happen, what research indicated that happens, is a decrease in prices, in cost, transportation costs, because of the salvage that Dr. Henderson mentions. So imagine that you are a mill owner, and then around you, the forest landowners around you was hit by a hurricane. So when these landowners were planning to harvest in 2-3 years ahead, they are harvesting now, and the mill will take advantage of that. But if you see this landscape, we now have a younger forest or not forest at all, which everything is being replanted. So now these mills have to go further from the procurement and then spend a little bit more on that. So this would be the effect on transportation. The intensity is the biggest challenge of this research, right? We know what happens, ups and downs, and we can talk about this further, but how much down, how much up, this is where parameters like the ones that Dr. Henderson mentioned is very important to have it. And also link it to jobs like from the Dr. Crosby or Chastain, which we estimated we're using remote sensing or using a spatial model where we can have a better idea what is being impacted on the ground, makes our model better too.
Yeah,
What about,
just
sorry, go ahead.
well, I was going to say to add on that, some of the other constraints for salvage short term is having enough loggers to get out there. Also, it's more dangerous, more costly sometimes to do salvage logging. And typically, in this situation of got an emergency on your hands, the people that are going to get the loggers tend to be the bigger, more established industry landowners, right? Because they have relationships. So having somebody already ready to go, having a logger friend would go a long way into you being able to salvage. So something we think about is, well, how can you get at least something? If you're hit by a hurricane, salvage is the way to do that. But and also, if you want to replant, you got to get the stuff out of the way, right?
I did notice with FSA, I talked with landowners in my extension role previously, that even though FSA typically for these disaster assistance programs will cut the check, it's all repayment. So the landowners are still having to come up with, to clear off the property, they still have to come up with the money initially. If they can find loggers that can remove the material, there's a little bit of a bottleneck there because, well, I may need as high as like $3,000-$4,000 per acre up front that the FSA people will get back to me, but that may be a year. So I think that's
FSA acronym.
it's Farm Service Agency. Sorry.
Yeah, there you go. Yeah, I just wanted to also mention that not all mills can take damaged wood or wood that may have an issue. There's quality limitations, and it varies by mill. But if you had mills that consume more pulp material, like Bruno was saying, that's an easier transition from salvage wood to a pulp-like product.
This may be a question for both or all three focus areas. Are timber companies sharing data on losses from hurricanes and tornadoes?
I'm not sure if they're sharing, but I know, for instance, the Georgia Forest Association is investigating the impact of the hurricane on Georgia, and they estimated 1.3 billion. So it's a combination between remote sensing, field activities. And I'm sure when we have this type of disasters, it makes easier to share the data.
Here's one from, I'm sorry, was somebody chiming in there? Here's a question from Mariah Mack. Can you expand more on restoration planning, thinning techniques to increase hurricane resilience while focusing on ecological objectives? Recommendations on a height or density cutoff to start thinning? Probably not a simple answer there.
I'd just jump in and say that anytime you're gonna thin, you're gonna change the risk to be higher risk for that stand for a short term. So that's something to consider.
Yeah. Go ahead, Jeff.
Yeah, I was just going to add, I'm not a silviculturist, so I'm not going to be as good at giving specific recommendations. There's a colleague, Seth Bigelow, has started to expand on some of that from our initial study that I was referring to that I can maybe drop in the chat in a minute here. Yeah, also I wanted to mention the trade-off between resistance and resilience too. The multi-age structure, having that multiple age structure, may make those tall emergent trees more vulnerable, but it also ensures that, if you do have a loss, it's not a total loss and you don't have to start all over. So in terms of ecological objectives, maintaining a lot of size diversity and all that stuff is key as well.
Yeah, I'll add just on the econ side. I mean, most people don't do it, but if the predictions are true that we're going to get bigger storms and more frequent in the future, it may be a good option to carry timber insurance. Now, again, it's cost prohibitive for most stands if it's over the entire life of the forest. But especially if you're in bad pulpwood markets, what we're starting to see now are a lot of people pushing their stand, the first thin being a chip and saw thin. So you flat out bypass pulpwood. There's some costs there, trade-offs in terms of quality, but it gets you out. It lets you keep the density in your forest so that you get the nice typical growth that you want. It protects the trees, the cohort effect. And most of what we see, at least from the econ side, from what I've seen, those trees are really vulnerable right after thinning, more so, than even 10 years beyond that. And so you could kind of carry that insurance. You don't have to carry it over the entire life of the stand. Again, there's a cost, but if you're in an area, again, Dr. Henderson, I think Dr. Da Silva mentioned this, right? The best answer is, well, just buy more forest, and then you've got insurance because you've got stands a bunch of places. If you're a small landowner, you can't do that. So insurance works well in that scenario, and also would certainly consider if you're going into a replanting phase, even though the seedlings are more expensive, considering longleaf pine. I mean, those trees are much more adapted from the studies I've seen to withstand these high wind conditions.
Yeah, Sean, just to build on the replanting, sometimes after a big hurricane, somebody they had their pine stand or whatever, it gets wiped out, and then they decide they don't want to replant, right? But the paper you linked, my paper showed that there's still plenty of, when you damage the timber long term, you're going to have a lack of supply. So if the replanting, you'll be able to capture that little delta of increased pine prices. I mean, if you look around today, you're like, oh, where's those pine price increases I'm looking for? But compared to the counterfactual of, if that storm didn't happen, really, even if you replant everything that was damaged, you're still not going to get enough timber ready to saw timber stage in time. So it's good to have things waiting in the wings, kind of building on what others have said. Sure.
Yeah, it creates the scarcity from a price standpoint, the landowner so much craves at this stage, right? Here's one for Christine. Is there an increase or decrease in invasive species presence growth after these hurricane events?
Yeah, that's an excellent question. And it depends is the answer. But generally, we do expect to see increases in forest pests and sometimes increases in invasive species as well, because the conditions the conditions post-storm facilitate the spread of a lot of invasive species, and obviously can also attract a number of forest pests. However, as I mentioned in my presentation, I believe was, it's interesting because we did a study after Hurricane Michael to look at forest pests, and didn't really find significant differences in the different kind of damage categories of, post storm. But it's also very difficult to get before and after pictures of what's going on, because you don't, ideally we'd have kind of long-term monitoring across, forests throughout the southeastern region, and then we could have baseline data that we can compare it to, but we have not really been able to do that. And we don't necessarily always see the increases that we would expect to see. And part of that, we think, with Hurricane Michael was due to the fact that it was a late season disturbance, right? And because phloem is an ephemeral resource that degrades very quickly. So the timing of the storm can really make a difference in terms of when pests might come into the stand. So if it's a late season disturbance, the phloem's degraded by the time that your beetles are out looking for new resources, and trees to infest. So whereas it's early season disturbance, right before, or at the same time that beetles are actually out actively looking for new sites to infest, that is a completely different story. So yeah, it depends on a lot of variables, but yes, we definitely generally expect or hypothesize to see an increase in, both invasive and native pests after a storm.
Yeah, I would say from a salvage perspective too, if climate warms, a lot of those effects from the timing of the storm and the general temperature matter, right? The wood decay is going to decay at a higher
Exactly.
rate, yeah, with the warmer weather. And so if we see that broadly speaking, over time, then my suspicion is you would see those insect populations rise as a result too. Yeah.
Right. And from a salvage perspective, also, it's kind of interesting that we tend to see the biggest increases in areas that have sort of a mid-range of damage. So there's the stands that are completely devastated, the ones that just have a little bit of damage, and then the ones in between. Often it's the ones in between where we see an increase in boring beetles in particular. But we think that's because there's still enough, a lot standing trees that are stressed, and it's those stress signals from the standing trees that really draw the insects in, right? And so when you have more of those that are kind of still alive, kind of hanging on, but they're really stressed, they're sending out more chemical signals. And so we actually recommend salvaging those sites first, to address any beetle concerns after a storm.
Yeah, that's a great point. Yeah, yeah. All right. Well, we've got a few that could call them more comments than questions. Carl, if you want to reframe a couple of those, we can get to them. I'm not sure what we can really provide on a couple of those, but we're right at 12. So let's switch over to the questions that I came up with that are really why people showed up, was the kind of the long-term future stuff that we can look at. And I want to, there's one question I want to get for geospatial stuff that I want Dr. Crosby to address, but we can address it within the context of these questions as well. Let's start with the first one here. From a research perspective, let's explore some next steps needed for ecological research. And within that, if you want to talk a little bit about why the previous studies are limited, not just in, well, the science wasn't there, but because there weren't enough forerunner studies, but what are some other barriers other than, well, this needs to get done first? What are some other barriers that could be stopping that we could also address from a funding model perspective and maybe a policy perspective? I'll give that one to Christine, Adam, and Jeff, whoever wants to jump in first.
I've got a couple thoughts, and I want to bring it back to one of the questions that got answered in the Q&A. Just simply, like, are hurricanes a natural part of the disturbance regime in these forests? And the emphatic answer is heck yes, which I think is really the missing piece of a lot of what we know and don't know about hurricanes and forest interactions. From a silviculture perspective, I'm really interested in understanding how stands interact and respond to disturbance and how individual species interact and respond to disturbance. Because if we know how trees and stands interact with disturbance, silviculture at the end of the day is just trying to replicate disturbance. That's really the only option we have. And so understanding more about these disturbance regimes, how trees and stands interact with those regimes, um, it really would help our management on the ground, from my perspective. And sort of I think the perfect example is Dr. Cannon's research with cone production and hurricanes in longleaf pine. And I'll turn it over to him uh, to talk about. But I mean, that's one of many interesting examples of adaptations from more infrequent events that we have a hard time testing, from a ecological and stand dynamics perspective. I'm sorry to put you on the spot, Dr. Cannon, but that's pretty cool
Oh,
stuff.
no, I love talking about that study. It was kind of fun to do. We did one study on, there was some lore among forest managers that longleaf pine is a masting species and has a very erratic and difficult to predict bumper crops of cone production. So if you're trying to manage it naturally, it can be somewhat difficult because it might be once every 7 to 10 to 11, 12 years. You know, who knows how often it's going to reproduce, but it seems to do so at particular regions. And there was some lore among managers that hurricanes may be causing that. So luckily there was a very long, I think almost, I want to say 60-year record of cone production in longleaf pine that were able to sync up with the hurricane records, and found, even though people have looked for other temperature and climate signals, they've all been a little bit equivocal. And so we were able to show that it was a pretty clear increase in cone production in the first year and the second year, 30% and then 70% increase in cone production. So we think that a lot of ecosystems might have some adaptations, or you know, that hurricanes are a part of the system. We think that the timing of precipitation, bringing in about 4 inches of rain during an otherwise dry part of the season, and you know, late September, early October, can be beneficial, and providing a massive amount of rain at once seems to stimulate reproduction. So that was one example, but we're trying to uncover all the other ways that hurricanes might actually be a part of ecosystems. This was done on longleaf pine, but we haven't done it on other species because we don't have such good records, but we suspect it might also be playing a role in oaks and a few others that we're looking at. But I wanted to add on, in terms of future studies, one of the things that I think is really missing is a complete and comprehensive risk analysis. And so people have done different pieces of this. So we just finished a study looking at you know, climatological records, and looking at what's the probability of a specific wind speed occurring in a particular area. So you can kind of get the event probability and intensity, but the severity, you know, how the forest is going to respond, depends on the species that are there and the management and the age, and all that stuff is very dynamic. From the bottom up, looking at field studies, Dr. Chastain mentioned the tree winching studies that can be used to look at rupture. Those are really difficult to do and have been done on a very small number of species. And then the modeling work that he's doing with gales, you know, so connecting you know, the individual species vulnerability to what the stand is looking like and how it's going to interact with wind. There are some people doing prescribed fire research and wildfire research where they're using fluid dynamics models to model wind and fire, the convection through a forest, and they've really got that nailed down. But you know, we'd be interested in, and there needs to be some work on trying to look at that fluid dynamics work on, you know, modeling different stand structures and wind speeds and arrangements. You know, could you, how much does adding a hedgerow protect your stand, or does, you know, feathering out with lower density on the edges so there's not such a strong barrier between an edge and a stand? You know, all those kinds of questions could be explored, but linking together the climatological, the stand level, and the individual species stuff, I think, has yet to be done.
Great answer. Thank you. Dr. Crosby, let me bring you in here. Been meaning to pick on you some too. From a geospatial perspective, I know you were telling me a while back that there have been some recent pushes forward in the technology, some of the LiDAR stuff. Can you talk about that to the audience and where, why you think that will have promise for research in this area as well as other areas of forestry?
Yeah, sure. I mean, basically, it's not really different than having satellite data or pictures pre and post event. I mean, you're getting some level of damage. The thing that LiDAR would do for you is let you look at, well, if the bowl is broken or the crown is snapped or whatever the case may be. You could also get measurements and biometric information, so you generate volume estimates, which ultimately would tie to dollar values. It might also help you figure out if you could get it quick enough, and you could if you had it on a drone or something, which stands you may want to salvage. I mean, if it's completely laying down, destroyed, and all of that, like Christine was talking about, those the wood that's still sound or more sound would probably be where they're going to go look first, or where they're going to go try to salvage, because that seems like that would be a little bit more worth their while, so to speak.
Thank you. This is one that, again, we're not picking on anybody here, but in terms of data needs, and this is an open question to anybody in the group. If you could talk to somebody who could, get the money directed to the right people, what data needs would you recommend as being kind of the highest priority? Things that we are lacking either in precision or in totality that we really need to get a better handle on, so that we could push things forward from maybe a more precision standpoint.
And resolution of inventory data would probably be a big one. Something like Landsat that matches up pretty well with a 5th acre forest inventory plot. But most people aren't going to have, states and the feds anyway, you're not going to get 100 or 150 plots. It's something the size of a county. You're going to have one for 6,000 or so acres. Obviously, there's a cost involved in that, and it's probably why most industrial forests are probably got a pretty good handle on what they have out there. To really nail down risk, and I did some work 15 or so years ago, and we looked at different forest types, like pine, mixed pine, hardwood, and hardwood. Hardwood damage is really tough to do because we were looking at southeast Mississippi, where it wasn't a lot. But typically, like the monocultured stands, like taller pine, particularly loblolly plantations, tended to get hammered, and mixed forest, and like Adam brought up, multi-age forests and more dense forests tended not to. We were fortunate, and this is another data need. We had some really high resolution wind data. It was the grid was like 1 kilometer gridded wind estimates for sustained and gusts, and it was from, the product was called H-Wind, and I looked it up this morning, and it is on a Moody's, it looks like, sells it, but we got it through the USGS, and I don't know if there was some kind of partnership or they bought it and released it, but we were able to download it. It was just accessible in the years after Katrina. But you can get that from them, and it goes, something like would go into Gales or something like that, would be a really high resolution wind data set, and something they've nailed down pretty well. The really tough thing, I think, with any of this assessing risk is going to be these storms are all different sizes. I mean, this has been hit on, but I mean, the recurrence interval in the Gulf is 5 to 10 years. So it's for landfall and hurricanes, so it's not going away. No two storms are the same size. The question about Helene a while ago, I think Adam hit it pretty good and Jeff did too. Soil type, soil moisture, duration and amount of rainfall. but the wind field with Helene was like 400 miles or something. I mean, that was a huge storm. So the likelihood that somewhere in what central southeast Georgia was going to get winds 70, 80 miles an hour, that would be tough to say a week out. Like, you know, Toombs County is going to get hammered, but they did. So I think something along the lines of probabilities of wind speeds and storms of different sizes and things like that. But I also think it's probably going to be a really tough nut to crack. But I mean,
Yeah,
resolution, spatial and temporal with data is good.
yeah, it seems like the papers I read, people were really good at predicting that particular storm. You know, R squared's as high as 95%, depending on what models you were using. But then when they tried to apply it to another storm, even one of similar, it was similar, right? Do big quotes there, size and damage, very, very poor in terms of its predictive power. So maybe that's.
And that could be a lot of things, probably like a orientation of winds to the coast. And Jeff, you maybe said that a while ago. Like if you've got straight rows of trees facing south and the winds coming out of the south at 100 miles an hour, I mean, you got a good canopy. You may be funneling the wind through there because it's a fluid and it spreads out and pushes into the crowns and breaks trees and throws trees and all of that.
Seemed like another area that was mentioned maybe the other week and a little bit maybe earlier today was a need for long-term experimental trials. Dr. Palenko, whoever else too, could you talk a little bit about the barriers there? I mean, some of them are fairly obvious, but nevertheless frustrating because of our inability to maybe convince funding that these are a need that needs some directed funds.
Yeah. So the study that I presented last couple weeks ago was on an experimental forest, and so that was a unique opportunity to compare some experimental, silviculture compared with some business as usual. Dr. Cannon is also in a very hurricane susceptible area on a property that has long-term ownership, which is really the key for all of this, because with long-term ownership comes long-term responsibility and costs of collecting those data. So that's really the biggest challenge, is that we don't, not only do we not know where storms are going to track, weeks before the storm, but ideally we have data that coincides with, those storms hitting that particular location, right? So, in a perfect world, we have a giant grid across the Southeast U.S. in many different forest ownerships across different management strategies and intensities, that we just kind of sit and wait for hurricanes to impact, and we have continuous monitoring of those plots over a long time period. And ideally those plots are measured every year at the same time, right? And so like you start building this wish list and you very quickly see how it becomes prohibitive, right? And so I think like a lot of this, whether we're talking about ecology or silviculture or like data needs, we're somewhere in between biology and reality. And so reconciling those two is a challenge we're going to face for a long time.
That grid setup of plots across the southeast might be a tough sell to any funder to fund something such long term. But I'll just add that funding can be difficult, and I'm right outside of my window in this long term area that's impacted by hurricanes, and I should be out there right now studying the now 7 or 6 year impacts of Hurricane Michael. It's right outside my window, but I'm not. Because other hurricanes come and distract us into immediate responses. So, one potential avenue that is starting to gain some traction are the satellite derived LiDAR data. So the NASA JEDI, and I can't remember, geospatial ecosystem dynamics, something, I can't remember the acronym, sorry, but it's a LiDAR satellite that's providing LiDAR information at a really large scale. It's not wall to wall like satellite imagery. It's, imagine a yarn ball. It's sort of taking small transects of the Earth, but it can be fused with other information sources to do this kind of constant wall to wall global monitoring that could be really useful. One other, maybe not data set, but area of interest that I think really needs more attention is the impact of the cumulative impact of low intensity storms. So, you know, whatever the wind field of Hurricane Helene was, we're really focusing on the areas that got the most severe damage. Well, there's a much larger area that got lower intensity wind that was not newsworthy, and several other hurricanes in the past that were maybe not newsworthy. And so looking at the cumulative effects of these lower intensity storms, I think could add up in terms of mortality and carbon and shaping ecosystems. And that's one of the areas of future research from our lab. I'm hoping to get some insight to that. It'll either be very interesting or not at all interesting. So we'll see which one it turns out to be.
Yeah,
Do you have something? Oh,
I have something. So in one of my most recent papers that was that maybe we'll link later, we use FIA data to and looked at the wind damage variable in FIA, and something like 1 to 4% of the forest is damaged by wind annually, you know, and so you keep doing that year after year. And what if you increase the damage rates over time? I think that's a good point about the cumulative impact. And also regarding the data grid, this is something that, you know, in my field, we deal economics, we deal with a pretty significant lack of data a lot of times, especially like transaction level prices. We don't really have a lot of access to those kinds of things, like what did landowner A get for their timber, landowner B, what they get for the salvage. So those kinds of data sets need to be developed so we can do a better job of understanding the economic impacts. But also, when it comes to salvage and timber supply, those are more aggregate, a bigger picture. So it's not just one landowner being affected, it's multiple landowners, and also timber can travel distances that, you know, maybe they'll go out farther to get the wood that's still in good shape because they need that high quality wood, and it's very complex. So it takes a lot of synthesis of a lot of different data sources.
all right. I did have one last question here. We're doing pretty good on time. I think we've got about 12 minutes if we go all the way to 12:30. So here's one from anonymous attendee. That's not your real name. Has there been any attempts to work with the effects of ice storms with high wind components? I'm not familiar with any. Anybody else that ring any bells? We're, you know, working in the Southeast, we don't face it a whole lot. What was that, Mike? You had one?
I think you see it occasionally, but usually, like you said, in the Southeast, we get an ice storm every 2 or 3 years, and it's terrible because we get a half an inch of ice on some of these trees, and the wind blows 10 miles an hour, and limbs snap, trees break, power lines go down. But I want to say it was, I'd have to look, 20 or so years ago, somebody did a study looking at like cumulative ice impacts or ice storm event impacts, but I think it was in the upper Midwest, Pacific Northwest, somewhere like that. But again, I would have to do some digging, but so you see it occasionally. And I want to say there was a pretty big ice event in the South a couple of years ago, and there were some, like here and there at conferences, you would hear a little bit about it, but it's, I mean, almost anecdotal, which is strange because it seems like it would be a good one. You're the only person doing it, right? If you're in the South.
All right. I think we're good on the questions. Anybody else have anything that we didn't touch on that you want to hit? We've got about 10 minutes. So any, last minute airing of grievances, as it were, about things that need to get done, or anything that the audience could take home that we haven't addressed. And likewise for those in the audience, if you still have any outstanding questions, shoot those into me.
I had one more thing to add to the kind of future research and data needs. So there was some talk about cumulative impact, which I completely agree with, and also compound disturbances, because what we tend to do is we study one disturbance at a type at a time, right? It's either a hurricane, or it's a tornado, or it's an ice storm, or it's a fire, or, and we need to, especially with sort of the projections of climate change and potentially increasing drought and floods and other types of disturbances that might get in the mix, that we need to have a better understanding of how compound disturbances are impacting our forests as well.
Good point. Yep. Yeah. Those partial equilibriums are easier for us to study, but they leave the picture incomplete, unfortunately. All right.
Now I have a
Yeah, please.
So one thing that I would be curious to see after this hurricane would be the land change, right? Like I think Dr. Henderson mentioned as well. But everybody knows timber prices are not the highest ever. Actually, it's kind of opposite. So I think several landowners will see this as if they're getting damage, you will see as an opportunity to switch to any other land use. And also, I've been talking to a few, well, they are like us, but they deal with agriculture, so they're agriculture economists. And there's a high interest in the U.S. South in terms of developing new technologies to convert timberland that was very hard to produce any food, but now it's becoming a little bit easier. So I'm just curious to see how these hurricanes can speed up the process.
Yeah, great point. Yep. Yeah, that financial decision gets a lot easier when prices are low and you've got a total wipeout. I know there is some research, well, not research, but some policy initiatives that come up every so often, typically after a big storm, looking at giving landowners the value lost on their forest. As it stands now, it's only whatever basis they have left in their account. So basis would be whatever you paid for the timber when you first bought it. So of course, 30 years down the line, or 15 or whatever, that basis hasn't adjusted for inflation. Cost and prices have, and so the basis matters less and less and less and less. But it's really hard to convince the federal government to give that claw back for those forest landowners. And so different people will tell you different things in terms of the likelihood of that legislation passing. But it is, at least in part, policy prescriptions that are being sought out to deal with these events, because they are, it is stochastic. We don't know when and where for a particular landowner they're going to occur. And so there's insurance could be private or public in this case. And I guess with a lot of the carbon biodiversity components to forestry, there could be an argument made for a public provision therein for recovery. So we'll keep our eyes open for that. But otherwise, it's, the answers are few and far between. So we want to look for resilience, or resistance measures, and try to attach those as much as we can. Making your forest robust against these disturbances, again, within reason, is really the route forward for individual landowners. There is an article in that link that I sent for the main webpage, talks about that. So if you're a landowner and you want to see kind of activities you can engage in prior to hurricanes, both long-term and short-term, and then recovery efforts after, a lot of it's maybe stuff you already know, but those could be valuable to you as if you have to make unfortunate decisions with respect to these storms. All right. Well, we don't have to keep everybody the entire time. Just like in my teaching, I try to be nice and let people go when we're done with the material. So, see, any more questions? I don't see any. Rita Newsel sent a message. Just wanted to say hi to Dr. Fortune. I think says you were an advisor on her senior project at UGA. So just giving you a shout out there. So that's nice. All right. Well, thank you, everybody. And for the attendees, just shoot me an email if there was anything you want to follow up on, and we'll try to help you as best we can. Again, thank you to the audience. Thank you to the presenters. Thank you to Dr. Barden and forestry webinars.net. And we'll see you next time.